Sarnoff Research Center in Princeton and joined UCLA, lucky for us, in 1969 in the School of Engineering, and I'm not even sure if we had a computer science department in '69, but shortly thereafter he was one of the founding members of the department. As we know, there are 3 seminal books he's written. There's been over 300 technical papers that he's authored. In 1995, the accolades really started coming in droves. He was elected to the National Academy of Engineering. In 1999, he received the Ichkai Research Excellence Award, which is given by the International Joint Conference of Artificial Intelligence every other year to someone whose contributions over their career have been astounding. That was back in 1999. In 2001, his book on causality won the Lakatos Award for the best book in the philosophy of science. In 2004, he received the Alan Newell Award from the American Association for Artificial Intelligence for seminal contributions to, and get this list, philosophy, psychology, medicine, econometrics, epidemiology, and social science. In 2008, he received the Benjamin Franklin Medal for creating the first general algorithms for computing and reasoning with uncertain evidence. He was a founding fellow of the AAAI and also a fellow of the IEEE. So without further ado, I'll give you Judea Pearl.
Thank you, Reed. Thank you, Reed. You don't know what I'm going to say. Well, after apologizing for, no, please turn it off. I'm going to hide the topic, yes. Now I'm really speechless. Before I just made a joke. But if I'll continue to be speechless, then I'll deprive you of a wonderful talk that I'm going to give you. When Adnan told me that there is a plan to do an event and asked me for a date, I asked him, what's the occasion? Is it my upcoming 75 years birthday, or my 40 years anniversary at UCLA, or is it the 25th anniversary of UAI conference? He said, neither. None. It's just a tribute to your contribution. Then it dawned on me that this is not an ordinary fest shift, the kind that universities are obliged to do to their retiring employees, but something deeper that carries a genuine recognition and appreciation. Recognition that the state of scientific knowledge perhaps couldn't be as polished as it is today if it were not for my work. And I'm really grateful for this recognition. And I heard today that I have impacted many people's life and career and thoughts. That also was not very clear to me, at least not to that extent. So I'm truly grateful for that. But then a scientific question came to mind. What does it mean, algorithmically speaking, to be grateful for being honored? Now, can you imagine one robot telling another, well done, and the other replies, thanks, I'm truly grateful for this honor. Now, what could it mean to Herbert? And I thought a lot about it, because to us AIers, things do not make sense until they make sense to a stupid robot. So let me share with you my definition or my proposed computational model of honor. And it should mean something like that the robot says, there's something right in my messy software. Okay. And then the question is, why thank for it? And the idea is that I thank you for signaling to me that my messy software is right, because it saves me time. Instead of spending all my time figuring out, should I revise the structure of my software? Should I reconfigure it? I just go ahead and do what needs to be done with the current software. A tremendous saving of time. So for this, I really appreciate you, the signals I got today. And this model is not incomplete, of course. It raises many unsettled questions. For instance, how come a robot does not know his own software? And what does it mean to reconstruct your software? Who is the reconstructor? Isn't it part of the software itself? And why say, thank you for giving me this honor? Why doesn't the robot say, why don't you thank the programmer who made me that way, who programmed me to act the way I do and to have the configuration? I will not elaborate on these unsettled questions. I would like instead to thank my programmers. The three or four factors that shaped my life, my messy software, and my work. So first and foremost, I owe gratitude to my teachers and to the educational system with which I grew. Having been an educator myself for the past 40 years, I can categorically state that in retrospect, my education was unique. My high school teachers were giants, one by one. These were Jews that came from Germany in the 1930s. These were professors in Heidelberg and in Berlin. They had left Europe at that time, terminating their careers as an academician, and took on a high school teacher's position. They knew that they will not write a paper anymore. They knew that they would not be recognized as I am recognized today. But still, they were totally committed because they knew that their children, their students, will continue the tradition, and they knew that they are building a nation that is devoted for excellence. And for this, I'm grateful to them. And I should also say that it was unique in the sense that they were all teaching us science in a historically based manner. Namely, when we learn about Pythagoras' theorems, the teacher came in and said, imagine yourself in the island of Samos, or wherever Pythagoras lived. Imagine yourself in 600 BC. What do you know? What do you ask? And what do you want to know? Okay? Every theorem in geometry was connected with the face of a Greek philosopher or mathematician. Until today, when I read the theorems, I see the faces of a scientist, the faces of mankind struggling with the uncertainty, struggling with the mystery of nature. And that, I think, is the kind of education that has disappeared today. I didn't see it in UCLA, and I wish it will be restored. And the same goes for my college teachers. I will never forget that my college education took place during the second miracle of Israel. The first, of course, was the war of 1948. Only 1% of the population was killed. And the second miracle, the one that is not in the news, is the miracle that a small society of 600,000 citizens tripled its size in 1 decade, and no one went hungry. Moreover, no higher education did not suffer any budget cuts. That was a miracle because that allowed me and my wife Ruth to get free college education in one of the best institutions in the Middle East. It is only now, 50 years after graduating from college, that we look back with awe and O, at the precious resources that were invested in us in those years, and again, by committed professors who knew that they have to build a model society, and scientific excellence is a necessary component in such society. Now, I never thanked those professors personally, and I never thanked them in public. I'm doing it today. Thirdly, my coming to UCLA was my third miracle. You know, at those times when I came in with the end of 1960s, in 1969, yes, industry looked upon academia with a sort of snobbish dismissal. What can academia do? What do they do there in university? And indeed, you know, the transistor and the lasers were not developed in universities. They were developed in Bell Lab, in IBM laboratories. Okay? And Ruth was pregnant at the time, and the IBM just came up with the, no, actually Fairchild came up with the semiconductor memory, which wiped out the magnetic memories and superconductive memories on which I worked, you know. And I was looking for a new endeavor. And it so happens that we kept the phone number that we received of Jerry Estrin that we received from an old relative of ours. And I gave Jerry a call. And he said, why don't you come down? Let's talk. And Ruth was gracious enough to have this intuition that only women have. And she said, what is going to be your salary cut? 50%? Take it. And she was pregnant at the time. And this was my second best, luckiest decision in my life. The first, of course, was marrying Ruth, but she claims it wasn't my decision, it was her. But Ruth's permission was not enough. When I came to Jerry's office, okay, at that time he said, yes, we have a slot or something like that. I didn't know what a slot is. But all I know is I did not fill any forms. I did not supply any reference letters. I did not apply for a job, and I did not meet any recruiting committee. All I know is that Lenny Kleinrock stepped into the office and looked me up top to bottom and said, Brooklyn Poly, never heard of it. But a week later, I was in Jerry's lab working. So that was a kind of hiring. I imagine there were many behind the scenes arm twisting and things like that. I'm not aware of that. And those were the happy times to be recruited. But to me, UCLA also meant a deep gratitude to colleagues and students. Colleagues for tolerating my idiosyncrasies and giving me all the freedom necessary to play my game of science. And to students, many of them are here today, who were able to take fragments of ideas and turn them into theorems and theories and systems. Thank you all. And finally, and truly finally, I owe much to computer science as a discipline and to AI as a paradigm. And let me explain. If 50 years ago, computer scientists were reluctant to attribute human qualities to machines, hesitating, for example, to use expressions such the algorithm thinks or my program decided. Okay? Today, it is rare not to attribute computational qualities to human thoughts. The ruling paradigm today in cognitive psychology has become, I compute, therefore I understand. Namely, the ability to emulate mental phenomena on a machine has become a mark, if not a proof, of understanding that phenomena. And the daring AI paradigm that says anything the mind does, the machine can do as well, viewed merely as a motivating aspiration, not a proven accomplishment, has given rise to scientific advances that could not be imagined under the more conservative paradigms, inhibited by questions such, what computer cannot do? One such aspiration has shaped my work on causality, and now I can entertain you with some slides. So here we should go back. this is my first slide. On causative counterfactual, or the subtle wisdom of brainless robots. So the problem of causality is as long as human history. Democritus already recognized the importance of causal reasoning and discovering causes. Einstein declared causation to be one of the great achievements of modern science by Galileo. The modern treatment of causality starts with Hume, who made several determinations, who made several proposals. One, that the distinction between analytical truth and empirical claims. And the causal claims he classified to be in the empirical side. And the third, that all empirical claims originate from experience. That means that causes too originate with experience. And to us, what makes us computer scientists pretend that we can add anything to these centuries of philosophical discussion, it's urgency. We have to make robots that reason about cause and effect, because they have to find their ways in the kitchen or a laboratory and be able to repair things that do not go as programmed, to be able to manipulate their ways in an environment, and when the environment does not comply with expectation, to do the right thing. And also, we have to learn how to teach robots, when we have the time for that, to teach the robots about our perception of cause and effect in our environment. And the second one is not as trivial as it looks. You might just say, okay, if you know cause-effect relationship, just write them down and let the machine follow the rules. Well, it isn't that easy, and I'll show you immediately why it's not that easy. The two questions that Hume faced, namely how we learn, how we acquire causal information and how we process it, now becomes two engineering problems. Okay? How should a robot acquire causal information from the environment, and how should a robot process causal information received from its creator programmer if we had the time to teach? And the second one is not as trivial, and here's my favorite example. The input could be, for example, if the grass is wet, then it rained. If we break this bottle, the grass will get wet. And the computer, just following the logical rules, will chain the two together and will come out with a ridiculous answer. If we break this bottle, then it rained. Okay? And that is not what is expected. Okay? So just following rule chains will not get, sometimes will not get you the right results. Another example by Lynn, I found it, I think it was your student? Yes. You have a suitcase, and it will open if both locks are open. The right lock is open. Query, what if we open the left lock? And the output is ambiguous, because the right lock might get closed. It's consistent with the constraints given to you by the first two input. Okay? So just solving constraint satisfaction problems is not enough. There's something there about persistent things in the world that is not encoded and should be encoded. We call it invariance. And by the way, my definition of causality is encoding of the invariant elements in the environment, in the world. Okay? But I would like now to show you what a brainless robot should discover and has discovered, or will discover if allowed to find its way in classical physics. Okay? First, I would like to argue that that robot will discover that physics is not properly taught in high school. Physics is taught in high school as a collection of rules, of laws of physics, and that arithmetic with algebra is sufficient to handle the laws of physics, which ain't true. I'll first show you that the laws of physics are non-algebraic. Let's take Hooke's law. Hooke's law says that if you have a weight on a spring, then the length of the spring is proportional to the weight. So let's write it down. The length is equal to twice, let's say the coefficient is 2, times the weight. So here I wrote down the Hooke's law, y is equal to 2x right here. And here I found that the weight is 1 kilogram. So I can solve it and get the solution, and it's written right here. X equal to 1 and y is equal to 2. Okay? According to definition, two systems of algebraic equations are equivalent, okay, if they preserve solutions. This is one definition of what equivalence is between systems of algebraic equations. I'm asking, is this set of equations equivalent to that set of equations? Okay? They preserve solution, but they are not equivalent, because that one allows me to ask more sophisticated questions. For instance, for this system of equation, I can ask, what if the weight was, or were, you say, what if the weight were 3 kilograms? And the answer is, if it had been, if x had x been 3, y would be 6. Every high school student can solve this problem. Even grammar schools can solve this problem. If we raise x to 3, y will be 6. Okay? That answer could not be obtained from here. Okay? Now, here comes the stupid robot story. Suppose you were given that problem to a robot. A robot will look at the two and say, what do I need? You told me that x is equal to 1. You're telling me now that x is equal to 3? It's contradiction. Sorry, contradiction. Okay? What a robot is missing is some element that we all do in our mind when we solve physics problem. We wipe out this equation and we write down the new given observation that x is equal to 3. We all do it in our mind. Every student in high school, when he solves physics problem, does it. The observation is now different. If we were to put a weight equal to 3, we wipe out this equation, we write x equal to 3, we solve these two equations, and we get the answer. The answer is 6, right? You must wipe out x equal to 1. Now, this wiping out is something that every child does in his head, and it was not revealed to physics teachers until they had to deal with programming it on a stupid robot. I had to deal with that because I was trying to get counterfactual out of structural equations. Okay? And I imagine what a robot would do given that kind of equation. And the answer is you must wipe out equations. The question is then, what kind of equations and how and so forth. It's a secondary, but first we have a new algebra. An algebra that requires wiping out of equation. We haven't learned that in high school. And that's an operation that needs to be dealt with. We computer science are very sensitive to new operations, new notations, and because of this sensitivity, okay, we recognize, wow, we have to deal with a new algebra. The old algebra, where these equality signs are algebraic equalities, is no longer valid. Okay? And that recognition came only because we have to program it on I call it brainless robot. So let's call our robot brainless, okay? Just to remind ourselves. Okay. The right equation should be written in the form of assignment. Y is assigned a value that is equal to twice the value assigned to the weight. Okay? Once you have an assignment, it's already directional. And that is what is meant by the counterfactual statement, not equality, not algebraic equality, but assignment equality. Okay? Once you do that, then you have to build an algebra for the assignment and an algebra for wiping equations. let's just generalize it now. Instead of one spring, let's imagine that the whole nature is a collection of springs. Okay? Every variable, every measurement is a result of some variable taking on a value, temperature, pressure, height, date, so on, and these are determined by some other forces. So imagine that nature is full of those springs, where nature looks at some variables, goes to some process, and assigns value to other variables. And they're all interacting. They can be feedbacks. And if you have this perception of nature, and by the way, I call it the scientific perception of nature, and I'll distinguish that from a non-scientific. Okay. If you have this perception, then everything follows. You just have a bunch of variables. Some of them you throw out of background variables. You don't want to deal with their explanations. Some of them are endogenous, and you have a collection of functions. Every variable receives a value which is equal to some function of other variables. Okay? Very simple, and that is what we mean by structural causal model. Okay? And if you want to play the game of uncertainty, you put distribution over the inputs of the u variables, and then you have a probability distribution on the u's, which propagates, and because you have a functional relationship, translate into probability functions on the v, on the variables, of the endogenous variables. Okay? So that's a very simple model. And for instance, you're all familiar with the linear structural equation, but this is part of this scheme, of this game of nature. Here's a simple example that I learned in my undergraduate in the Technion, but everybody understands that this is just a collection of functions. Okay? And the nice thing is that this one is an oracle for counterfactuals. For this scheme not only predicts the outcome or the output in terms of the input, but it can also answer counterfactual questions. For instance, what if I were to connect Y to a power supply of 3.5 volts? Or what if that variable, or what if this gate were an OR gate instead of AND gate? An engineer can look at the schema and tell you the answer. Where does the engineer get the answers, and where does this representation get its power of expression? The designer of this circuit did not anticipate such crazy operation as replacing this AND gate with an OR gate, or connecting this to a power supply. And still, you are able, as an observer, to answer all these counterfactual questions on the basis of what? On the basis of functional description of the world, and on the basis of an assumption that when you take an action and replace this gate, the other gates remain intact. And this is the modularity idea. Okay, now we have a perception of nature, a scientific conception of life, if you want, and we can do almost everything. I'm not kidding. We can just, brainless second discovery will be that counterfactuals are embarrassingly simple, because you have a collection of functions. So to compute a counterfactual, the sentence y would be small y in situation u, had x been small x, denoted by, it's hard to see here, y subscript x of equal to small y, it means simply that the solution for y in the mutilated model of equations, namely the one where the equation of x is replaced by constant, is equal to small y. It's a statement about what will your solution be if you were to sit there, wipe out certain equation, and solve it. Now, every high school kids know how to solve equation, and that's why I'm saying it's embarrassingly simple. Okay? The semantics of counterfactual is very simple. Computationally, it becomes a computer science exercise. But there's no mystery here. There's no mysticism, and there's no metaphysics. Okay? Counterfactuals are really not only part of the scientific conception, it is the building block of physics. So there's nothing special about counterfactual. The whole physics is one big counterfactual system. And the next thing is we have the fundamental equation of counterfactual. Please inscribe this on my tomb. Because I'm going around with this, I'm trying to peddle it for the past 5 years. And most of my colleagues agree with it, okay? But they don't care, they don't use it, even though it can solve all their problems. I'm serious about it. Solve, I mean, in the mathematical sense, not in the computational sense. I'll show you what it can do for you. This, I call it the fundamental equation of counterfactual. It means that the counterfactual, here, right here, I'm just repeating what I wrote here. Y would be equal, the value of y, had x been small x, is equal to the solution for y in a mutilated model where you wipe out the equation for x. Okay? Nothing could be simpler than that. What it gives you? It gives you 1. Joint probability of counterfactuals, well defined. Give me a structural equations with the probability on the input. I can compute for you the joint probability of any 2 sets of counterfactual, okay? Y would be equal to small y had x been x, and simultaneously, even though they are contradictory, simultaneously, z would be equal to small z had w, some other set, been equal to small w. Right? Solve the equations. Nothing there. And find the probability, sum up over all the weight of the input that satisfy the required condition. Well defined. Algorithmically, wait a couple of slides. In particular, causal effect. Probability that y, if I were to do x, which we identify with the probability that y would attain the value small y, had x been small x, it's well defined. The probability of what Jamie and Sander call the probability of causation. Okay? It's the probability that the patient who died and took a drug would have been alive had he not taken a drug. Okay? I'm just putting names into the symbols, okay? It's well defined. Although it sounds, metaphysical. The guy is dead. What do you mean if he were alive? It's not metaphysical, it's right there. It's well defined. Okay, once we have it, we go one step further. We have, using that, we have a data generating model. And instead of statistics looking at joint distribution to be the oracle of all queries, we now have a data generating model to be the oracle of everything we want to ask. Okay? And what we are searching for is an answer, is an aspect of the data generating model as a function of the data. This is our exercise now. And what is M? M is the invariant strategy, sometimes called mechanism or recipe or law or protocol, by which nature assigns value to variables in the analysis. So that means that you have to imagine nature assigning values, which means that you are thinking nature and not experiment. And that is the difference between the scientific view of the world and the statistician's view of the world. The statistician thinks, what experiments do I do to define something or to measure something? And a physicist thinks, what happens in nature? Right? Of course, in order to justify claims of the scientific view, we have to do experiments. But the thinking goes in nature. For instance, right now, I look in your face, and I'm telling you with certainty, not as a scientist, that the world behind me remains invariant even though I'm not looking at the wall. And I'm not conducting any experiments to prove it. I just assume that. And that was one of the ideas of the Simpsons, in his 1755 paper there, where he got the idea that when you measure celestial objects, and he wanted to prove that the average of measurement is closer to the truth than any single variable. What he did, he imagined that there is a true position for the object. And he invented the idea that the error is the difference between what you observe and this hypothetical thing, the true objective position of the object. Okay? So imagine things which you don't measure. You just assume. In the same way, I assume that the door here exists even though I'm not looking at it, and I assume that the temperature everywhere is determined by some process, natural process, and that the disease of every patient is determined by some natural process. Okay? It is given by some equations, and I don't need to know the equations. The exercise of coming out with identifiability and estimation is an admission and confession of ignorance. It means I don't know the equations in the model, and I don't know the probability on the input. What can I do with my ignorance? That is a. But first, you have to start with the wishful thinking, with the Santa Claus kind of imagination that there is someplace an equation and there is someplace a probability. I don't know them, but just committing yourself to their existence already puts you in a different frame of mind. I like to demonstrate that in a puzzle that became classical in philosophy, and it's a puzzle of a counterfactual consensus. You mentioned that people dealing with actual causation, their criterion for success is matching 42 canonical examples. Okay? And that's not scientific. But it so happened that in case of counterfactual, people form consensus. And the purpose of philosophers is to find out how is it possible that people form consensus. Okay? Can we find an algorithm or a representation that can explain this miracle? Look, it came out, by the way, it was invented and attributed to Ernst Adam. He was professor of philosophy in Berkeley. He died last year, I understand. If OSWALD didn't kill Kennedy, someone else did. Most people will agree, unless you are smart Alex and you say all kind of thing. But most people will agree, yes, I will assign a truth value of true to that sentence. When you ask in a subjunctive mode, if Oswald hadn't killed Kennedy, someone else would have. Most people will say, no, I don't think so. Okay? So here you have two counterfactual. Yeah? And with the little knowledge that we know about the politics of Texas, of Dallas in 1963, we are able to form a consensus. Let's call for some explanation. Okay? Computer science explanation, not philosopher, because philosopher goes here. Hume says, we may define cause to be an object followed by another, and where all objects similar to the first are followed by the object similar to the second. That's a definition of cause, by the way. Or in other words, and here comes the counterfactual, where if the first object had not been, the second never had existed. Okay? That was Hume's definition of cause in terms of counterfactual. I'll get it. The same thing with Lewis in 1986, explaining cause in terms of counterfactual. A has caused B, it's actual causation, by the way, if B would not have occurred if it were not for A. Good. My question is not whether these definitions are right or wrong, but how come two pillars of philosophy are attempting to define causation in terms of counterfactual and not the other way around? Why do they choose counterfactual as a basis for defining causation? Is it mentally clearer? Is it less problematic? Apparently, yes. Otherwise, these two giants in philosophy would not resort to counterfactual to explain causation. Okay. So if they did that, it means that our mind is equipped with machinery to process counterfactual information swiftly and reliably. And if that is the case, then it becomes an AI exercise. How do we do that? It could be mysterious, right? If you do it so swiftly, it couldn't be metaphysical. It must be simple, high school. It is high school. This is Lewis' definition of counterfactual in terms of possible world. So here's our world, and here is a statement: B will be true if it were A, when just in case B is true in all closest A world to W. Here are all the A world. Some of them are closer to us than others. And if it so happens that the closest A world to our world happen to be E and B, then we say the counterfactual is true. Okay, that is Hume's definition there. Now, you're talking about here about the measure of closeness, measure of similarity, and that calls for some ambiguity. Because think about Oswald and Kennedy. Okay? Had Oswald not killed Kennedy, somebody else would have. Is that, what is the closest world to Oswald not killing Kennedy? We know that Kennedy is dead. Should we maintain this proposition in order to form a closest world? No, right? If Oswald did not kill Kennedy, we probably imagine that Kennedy would be alive at least a year after the incident. Okay? So the idea of closeness, similarity, is not well defined. How can we form consensus if we have an ill-defined term? That is the question. My proposal was very simple. We have a collection of, there's no similarity in my definition. Right? It's just a high school mutilation of equations and finding solution to a bunch of equations. So if you and I share the equation of physics, okay, then we can explain the consensus we form. We can differ on our equations, in a set of equations. But if we share a set of equations that describe our physical world, then we should form a consensus about every counterfactual query, except for those that involve many variables, and then we get into problem of reliable computation. Okay. Here is our brainless robot trying to figure out how to distinguish between the indicative and the subjunctive queries, sentence 1 and sentence 2. Prior knowledge is, you have agents like Oswald, like someone else, I call him SE, and they might have some motivation, the motivation of someone else, motivation of Oswald, and if any of them shoots in the right direction, then Kennedy is dead, that's K, okay, dead. And we have some prior probability on SE, on OS. That's prior knowledge. That's a general knowledge. We just instantiated it to Oswald and to someone else. But it is general knowledge about shooting and killing. And now comes the evidence we have. We learned that Oswald killed Kennedy. So we instantiate these two nodes to true, true and true. Well, we read the papers. Now we propagate the belief. We propagate them to all other variables. We find out that the probability of someone else killing Kennedy remained the same, did not change because of the explaining away effect. Okay? If you propagate, believe me, if you propagate the information, you find out that the probability of SE remains the same as here because the Oswald killing provides already an explanation. We don't need to suppose that the probability of someone else killing it is increasing or decreasing with that information. Right. So we propagate the information upward, and we get the equality here. Okay. And now comes the counterfactual. No, not counterfactual, the conditional. If Oswald didn't kill Kennedy, someone else did. How can we verify it? Here we learn that Oswald killed Kennedy. Now we change the evidence. Instead of true, maybe Oswald produced an alibi. Okay. So we imagine that evidence is produced here, is observed, that refute the hypothesis that Oswald killed Kennedy. So now we have false here and true here. We propagate the information, and what do we get? Bing. The new probability of someone else become true, because you need to explain Kennedy being dead. Kennedy being dead, Oswald did not kill it, someone else did. So it becomes true by simple propagation. And so it's a simple evidence propagation we have here for the indicative sentences. Okay. Are you with me? Everybody knows belief propagation these days. Now let's go to the subjunctive. Again, we start with the general knowledge about the general effect of causes. Again, we read the newspaper. Oswald killed Kennedy. Kennedy is dead. Oswald killed. We propagate, and we find it's the same thing. Okay? And now comes the subjunctive. Now, assume that Oswald refrains from killing. That is our interpretation of that. If Oswald hadn't killed Kennedy, how do we process that information, that conditional, that antecedent of counterfactual? We process it by counterfactual. We maintain from the previous world everything up to that event, namely that Oswald had a motivation. The motivation there is true. So we transform that here. The past does not change. Only the future will change. How? By wiping up equation. Whatever mechanism caused Oswald to pull the trigger, that mechanism now is dead, is mutilated out. For some reason, Oswald either regret or his trigger gets stuck or some miracle. Lewis called it miracle. And we have a situation like that. Oswald does not kill Kennedy. His motivation is still there. And when we propagate this information, we find out that the probability of someone else killing Kennedy remains the same as it was in the prior information. No change. There's no reason for us to assume that someone else would have done it. Okay? It's a very simple belief propagation exercise with one change relative to indicative interpretation. Namely, you wipe out this link, and you also you do not maintain the information that you obtained earlier about Kennedy being dead. You allow that to be developed on its own. You rerun history with a little bend. The bend is right here, between the motivation, between the past and the actual action. But notice that the information that that we read in the paper, that Oswald did kill Kennedy, and Kennedy is dead, has a residue here. The fact that the motivation is there. That maintained there. If, for instance, the model was that there is a conspiracy to kill Kennedy, then the fact that Kennedy was killed by someone already transferred this information of true to Mr. someone else, SE, okay? And that will change the answer. And indeed, intuitively, if you suspect that there was a conspiracy or there was resentment or political hatred toward Kennedy in Texas at that time, then this information, the fact that Kennedy was killed, will be transferred on to the counterfactual conclusion, and you end up with, yes, it's more likely that someone else would have. So it's mechanized. Now the counterfactual queries, here in the classical example of philosophy, okay, it has been reduced to algorithmic exercise. By virtue of whom? By virtue of Mr. Brainless, that wanted to see how things work in algorithmic details. Because the Mr. Brainless, the robot Brainless, could not follow the idea of closest world and similar world. It was too ambiguous. Oh, am I exceeding my time? No. Good. Well, I don't have many things to do. The Brainless' third discovery is that high school counterfactual can also be useful, not only in analyzing examples such as OSWALD killing Kennedy, but also in many fields such as economics, social science, epidemiology. It solidifies and unifies, I think, all. But I'm sure if I say all, I'm going to have arguments with my colleagues here. But what are other approaches to causation? And this includes the potential outcome, the structural equation models, decision analytical, the probabilistic analysis of causation, the, what is that, I forgot, the sufficient causation of Rothman, the causal power of Chen. It's all special cases that are focusing on a certain subset of problems of the general structural equation models, or the causal model structural causal models that I described before. And it also happens to demystify many enigmatic notions that have caused problems and misconception in the field, such as ignorability. I'm just mentioning it for, if any of you are from economics department, exogeneity. You know that books and volumes were written about exogeneity, and no economist that I know can tell me what it is. Exchangeability, confounding, mediation, attribution, regret. These notions have been problematic, and they receive now very simple definition. I'm not saying anything about estimation now, because that is a separate issue. But once you define things, you can ask the question: is it identifiable? And you can answer it mathematically, yes or no. And that's a great help. If I give you 3 equations with 4 unknown, I know how to tell you that the answer is no. You don't have enough information, and save you a lot of work. That was a great innovation in algebra. Okay? And here, if you ask me, do I have a sufficient information, okay, to identify things, to estimate things consistently, okay, my ability to tell you, no, you don't have enough, is a tremendous achievement. Okay? So Mr. Brainless is really happy. And plus resolving lingering puzzles, I will end it up with my conclusions that if Oswald had not used counterfactuals, Brainless would have. And this should make us all wonder how much of modern scientific thoughts is owed to brainless robots, namely to the disciplines of computer science and the paradigm of artificial intelligence that force us to explicate things in algorithmic details and force us, knowing that those details must be taught to brainless robots, and in this way, not only to achieve robot emulating us, but us understanding ourselves. And to paraphrase Descartes, I would say, I compute, therefore I think. I came to the conclusion of my address. Allow me only to say a few words about my other lives. My other lives. You know that my son was killed brutally in Pakistan in 2002, and since then I've been devoting most of my free time, if I have any, to a foundation that was formed in his name, whose mission is to roll back the hatred that took his life. And we do it in 3 different areas, in the using his style and using the 3 communities where we have leverage. Journalism community, musician, because of his love for music and his being a musician, and a dialogue. I engage a lot with the dialogue with the Muslims, trying to find a common ground between Muslims and Jews, and to air the differences, to see if this planet of ours can be redirected into a more reasonable orbit. And I would also at this point like to thank very much the organizer of this event and the editor of this wonderful book, which I'm still wondering why I don't have a paper there. I would have liked to participate, but it was a surprise to me, and I appreciate you trying to keep it a surprise. I only got few hints, mainly from my wife, from Ruth. Something is cooking, and she mentioned the word fest shift, but I thought it a fest shift, you know, some sort of a festival of Purim festival or something. But I didn't realize that you'll go to the extent of producing such a wonderful book where I can read and find out what I missed in all these years and all these areas which I have abandoned so unwantingly. Thank you very much for being here with us.